All right. Hi, guys. Welcome to some new notes. We are on in section 1.3, part 2, and this is on solving multi-step equations. Write at least that part down. You don't have to write what's in the parentheses, but I wanted to include that some of this solving that we're doing is going to include problems where we have to simplify by either distributing or combining like terms first. So the first thing I want you to write is when solving a multi-step equation, you need to undo the the operations in backwards instead of writing order of operations, I'm just going to write PEMDAS because I know that you guys all know that. So when you're solving these multi-step equations, you want to undo everything that's happening to your variable, like your x or whatever letter it is, and you want to undo all the operations happening to it in backwards PEMDAS order. I'm going to go to a new slide, so pause it if you need more time. So off to the side here, I'm going to write, just going down my page, PEMDAS, to remind myself when I'm evaluating an equation, I do PEMDAS in the right order. First I evaluate the parentheses, then any exponents, then multiplying or dividing, and then adding or subtracting. When I'm solving for a variable, I want to go in the opposite order. I want to undo any adding and subtracting first, then multiplying and dividing, then exponents, and then anything in the parentheses. So we're kind of working from the outside in here as opposed to the inside out. So let's try an example of this. Our equation is 3w plus 7 equals 19. All right, and our instructions would be to solve, and that means solve for w. Find out what w has to be. So just like the equations we were working on last week, we're going to draw a line through the equal sign because that reminds me that I have to do the same thing to each side of the equal sign. I have to keep it balanced. So if I'm looking at my w here, he wants to be all alone on his side of that line. That's like his house or his yard. He wants everyone else out. So we have two things happening here. We have a 3 being multiplied to the w and a 7 being added. So we need to undo those in opposite order of operations. So I've got multiplying and adding. I have to start with the last thing in order of operations, which is adding in this case. So I'm going to undo that plus 7 by subtracting 7 from each side of the equal sign. Then I like to draw a line to write down what I have left. So 7 minus 7 is 0. We don't need to write that anymore. We can just write 3w on this side. On my other side, 19 minus 7 is 12. Now I just have a one-step equation like we talked about before. We need to undo the 3 being multiplied to the w. It's right next to it, so it's being multiplied. To undo multiplication, we divide. That's our inverse operation here. So now w equals 4. You can plug that back in to check. If I plug it in my equation, 3 times 4 plus 7, 3 times 4 is 12, plus 7 is 19. So it works. W equals 4. All right, we're going to do one more example together, and then I'm going to give you 2 to try on your own. All right, so here's another example. This example is m over 3. Remember, that means divided by 3. Plus 4 equals 6. And I'm doing backwards PEMDAS order here. So I draw my line through my equal sign. I find my variable that wants to be alone. I have two things happening. I have a divided by 3 and a plus 4. So I have division and adding. I have to undo the adding first. So to undo adding 4, I need to do the inverse operation and subtract 4 from each side of the equal sign. That's why we draw that line there. Draw a line to write down what you have left. Positive 4 minus 4 is 0. So we don't need to write that anymore. We can just write m over 3 equals 6 minus 4, which is 2. And then now we're down to a one-step equation. So to get rid of divided by 3, we want to multiply by 3. And I like to write it on the top because that shows me it's 3 on top, 3 on bottom. 3 divided by 3. I need to multiply by 3 on both sides of that equation. So now I'm left with m equals 2 times 3, which is 6. I can plug that in. 6 divided by 3 is 2, plus 4 is 6. So we know that it works when I plug it back in. All right, I'm going to give you 2 examples to try on your own. I want you to try these, and I have a code word for you. The first code word is pig. So write down the word pig. Write it at the very top of your notes, the very beginning. I'll check to make sure you have the first code word. Pig. All right, here's 2 examples for you to try. First is 2g minus 13 equals 3. I want you to solve for g. And for b, 5 equals z over 4. Sorry, z over negative 4 minus 3. Go ahead and try those 2. This is a z, by the way, not a 2. That's a z. Pause the video, try those, and we're going to come back and do a couple more examples. All right, our next example, we're going to get a slightly bigger equation. It is h plus 6, all of that is over 5, equals 2. So remember, we're still working in backwards PEMDAS order. Now, we also want to work from the outside in. Okay, so this one gets a little different. This h plus 6 is on top of a fraction. Remember that a fraction kind of represents grouping. That whole quantity is being divided by 5. So even though the 2 things happening to our h that wants to be alone are adding and dividing, I know that adding comes first if we're doing backwards PEMDAS, but we can't just subtract 6 right now because this is not really a 6. This 6 right here, it's actually a 6 divided by 5. If you remember the heart method from last year, you'll know that's not a 6. It's 6 divided by 5. So since we're working from the outside in when we undo things, we need to undo this divided by 5 first before we can free that 6 from the grouping symbols, the invisible parentheses that it's in. So to get rid of divided by 5, I'm going to erase my example right here. We need to multiply by 5 on both sides. 5 over 5 is 1, all right? And the reason we can get rid of that right now is because this whole quantity, h plus 6, is divided by 5. So for multiplying the whole thing by 5, it undoes that. 5 over 5 is 1. So we're just left with h plus 6 equals 2 times 5, which is 10. If you have a question about how that works, write it down and we'll go over that tomorrow. Now we just have a one-step equation. H is being added to 6. We don't want that, so we're going to do the inverse operation and subtract 6, and we're left with h equals 4. You can check it. Plug it back in. 4 plus 6, if I plug it in right here, is 10 divided by 5 is 2. So we know it works. I'm going to give you a similar example that I want you to try. Try solving for d here. D minus 8 over negative 2 equals 12. Follow along the last example and try that one. All right, I've got 2 more examples for you. Okay, and I've got another code word for you. Write it down at the top of your notes, right under pig. It is blue. I guess I shouldn't have said the first code word, should I? That kind of gave it away if you skipped to this part. But go ahead and write down blue. It's your second code word. All right, so we're going to do an example. It's a little longer here. We're going to have to do some simplifying before we solve it. So write down negative 12 equals 9x minus 6x plus 15. So before you even start trying to get your variable by itself here, you probably notice that you have a variable in 2 places, 9x and 6x, or negative 6x. So what you want to do is before you start solving it, go ahead and simplify by combining like terms, then solve it. So we know we can combine 9x, take away 6x's, is 3x. So we're actually left with 3x plus 15 is just hanging out right here, equals negative 12. Now we're down to a regular, this is just a two-step equation. We can solve that by drawing a line through our equal sign, locating our variable, and then undoing the operations happening to it in backwards PEMDAS order. So what I'm seeing here is a multiplying from the 3 and adding from the 5. So we have adding and multiplying. We need to undo the adding first, then the multiplying, because we're working in backwards PEMDAS order. So to undo adding 15, we need to subtract 15 from each side of that line. If you're simplifying, you don't have to do it to each side, like when we combine these like terms. But if we're actually taking something away or adding or doing an operation, you have to do it to both sides. So we've got over here, negative 12 minus 15 is negative 27. And over here, 15 minus 15 is 0, so we're just left with 3x. And now it's just a one-step equation. To get rid of that 3 that's being multiplied, we need to divide, because division is the inverse of multiplying. 3 over 3 is 1, so we are left with negative, I can't even think about this right now, 9 is equal to x. And I'm just going to rewrite this because we like to write our variable first. X equals negative 9. I'm going to give you one to try. You're going to have to simplify by combining like terms first. So go ahead and try negative 2x minus 10x plus 12 equals 18. Try that one on your own and see what you get. All right, I have one more example and then one for you to do. So the last example we're going to do together is going to involve simplifying by using distribution before we actually solve for our variable. So go ahead and write down this equation. It's 2 times the quantity, 1 minus x, and then we're going to add 3 equals negative 8. So before we even try to solve for this x, he's kind of trapped in those parentheses right now. So what we need to do is distribute this 2 to the 1 and the negative x, or you can think about it as a negative 1x. His coefficient is negative 1, before we can solve. So 2 times 1 is 2, and 2 times negative 1x is negative 2x. I just multiplied 2 times negative 1 to get negative 2, and the x, there's no other variable to multiply by, so he stays the same. Now we still have the rest of this equation. Plus 3 equals negative 8. Nothing about that changed. We just distributed the 2 to what was in those parentheses. Now, kind of like the last equation, we need to simplify this first. I mean, you don't have to, but it just makes it easier, because if you can combine terms like this 2 and 3, you might as well. So we've got a 2 and a positive 3. Well, 2 plus 3 is 5. So go ahead and simplify that. It'll make it less steps later on. We still have the negative 2x, so minus 2x, and it still equals negative 8. Now we've got just a basic two-step equation here. We need to undo everything happening to x in opposite PEMDAS order, opposite order of operations. Here's our x. Two things happening here. I see a 5 out here. It's a positive 5. It's being added or subtracted. It's positive, so I like to think about it as adding. And we've got a negative 2 being multiplied to x. So we have, you can think of it as adding or subtracting. It's a 5 added. Subtracting is really just adding negative numbers. And we're multiplying by a negative 2. So we need to undo this addition first. To get rid of a positive 5, we need to subtract 5 from both sides, because 5 minus 5 is 0. And 0 minus 2x is just negative 2x. On the other side, we're left with negative 8 minus 5, which is negative 13. That is actually negative 12, isn't it? No, it's not. It's negative 13. Sorry. So then when we simplify that a little farther, we're going to divide by negative 2 on each side. Negative 2 divided by negative 2 is 1, so we're left with just 1x, or just x. And negative over negative is positive, so I wouldn't mind if you left this as 13 over 2, or you can write it as 6 1/2. Either one is okay. All right, one more for you to try, and that's the end here. Okay, I want you to try solving this. 15 equals 5 plus 4 times the quantity 2d minus 3. You're going to have to distribute before you can solve that. All right, and then your last code word is Witzel, like Witzel Wednesday. That's your third code word. It's W-I-T-Z-Z-L-E. So write that down on the top of your notes. You should have 3 code words now. All right, see you tomorrow. Come with any questions and we'll go over these notes.